Good afternoon. Did you have a good lunch? My name is Byung-Hyun Yu. I'm one of program chair of Web3D2013. I will be introducing today's invited speaker, Alain Chesnais. He has over 25 years of professional software development experience, and he served as president of the Association for Computing Machinery. I think the audience in this room, there is no one who doesn't know about ACM. So, and the world's largest educational and scientific computing society from 2010 to 2012. He is a recognized leader in computer graphics software development. He has been professionally engaged either as founder, president, vice president, and chief technology officer in many companies, including API, Tucows, TrendSpottr, SceneCaster, and TrueSpectra. Alain Chesnais was also a director of engineering at Alias wavefront on the team that developed the Technical Academy award-winning software Maya package. He was also president of ACM SIGGRAPH between 2002 to 2005. Please join me in welcoming Alain Chesnais.
You start wondering how old you actually are when you hear that your bio takes about as much time as your talk. Anyway, I hope you've had a good lunch and that you're not thinking of taking a siesta. I will try to keep this animated and give you a little bit of insight as to things that I worry about when I look at 3D on the web today. How many of you were at my keynote 2 years ago in Paris? Okay, a fair amount. So last time I gave an overview of pretty much how we got to where we are, looking at various horror stories and other little anecdotes about the types of problems we had to face as computer graphics matured, going from a 9600 baud connection to my frame store from my original VAX when I first started, to various issues that came up. So I thought that for this one I would bring it up to date and take it for the next steps and look at where we are today. Look at some of the things where we're almost there, we're so close. Web3D is pretty much a reality except for a couple of cases. So I thought I would go and start off with a little story. And it's a horror story. This is the last project that I actually worked on using Web3D. And I was very happy to meet Ricardo here because I was using Free.js to be able to do it, had a lot of fun with it, loved it, but ran into a couple of issues, and I want to go into those, to look at how we might address those, and what sorts of things we can do about it, given where we are, and what we can expect to see over the next couple of years. Okay? So first, let me introduce you to Pat. So this picture was taken 2 days ago when Patricia Beckman-Wells basically was granted her PhD. So Pat is somebody that I've worked with. She's an avid SIGGRAPH volunteer. She's worked on many conference committees and is full of energy and a very, very creative person. She was doing her PhD at USC in education and was looking at some creative new uses of technology to see what you can do with very young children and how we can use the technologies that we work with in that scope. So let me give you a little bit of background on this. So, as I said, Pat is doing her PhD in education, and as I said, she was actually granted a PhD. So I didn't screw everything over and help her out. We actually did manage to get a PhD. She came up with a brilliant new model in terms of how you can teach very young children, so children where we don't expect that they actually know how to read, where we can give them interfaces that use full gamut of everything that's possible on the web, including 3D, to help children develop their creative skills. So if you look at the computers that are available, what everybody has access to in many of the developed nations and what we could currently do, we're only using a small part of what's actually available. What I was proposing to do is to extend that, to make it a lot more immersive, to look at different types of elements that we could use and see how we could develop children's creative skills. She'd set up a network of people that she wanted to go and test this with, so it sent out a call where she'd asked for educators, for parents who are homeschooling, to test out the software that we were going to write. And in doing so, she actually built up a fairly consistent and large network of people who got very, very excited about the project proposal. There was a lot of discussion, lots of message boards, people suggesting ideas, and getting excited just by the description of what we were going to build. And one of the key elements was that Pat thought that this would be an ideal place to use some 3D technology to try to look at more immersive models in terms of what we could present to the children. To give you an idea, this is actually taken from the software, so these are two 3D models. This is Gertie and Murphy, who are two key characters in terms of what's actually going on. They're monsters, and they interact with the children. They actually go and help them out. So the way it works is that these two monsters are consistent throughout the whole user experience. Okay. So let's look at the workflow a little bit. So what we've got in terms of this first lesson, so what we've built out is an infrastructure that will let us go and build out more of these. So this is just the first project in terms of what we do for a PhD. The plan is to actually go and build out more and gather more data as we test to see how children interact, what they do, what works, what doesn't work, and then feed that back into the model. Okay? The original lesson plan had 11 separate lessons building up on children's skills as they learn the various elements of storytelling. So the idea was to go and bring a child who had never written a story, or in this case, these would be videos themselves, and teach them what's involved. What are the key elements of storytelling? How do you actually get that to work? And what is it you have to work on to be able to have a successful story that will engage people and get them to enjoy their experience? So each lesson has a video associated with it. The video gives you the premises of what's available, what you can do, and what you're expected to do in that lesson. The two monsters that I showed you earlier are there to provide help. So basically, whenever you watch the lesson, the system follows which is the most recent lesson you've watched, and if you go and interact with the monsters, they'll show you how they answer the questions that were being asked in the lesson. Okay? So it's a very, very simple model, very interactive. The kids actually pick it up very, very quickly. It was actually fairly surprising to see how easily the kids picked this up and understood what they were expected to do. One of the interesting premises of this whole exercise was that what the kids were actually doing was they were drawing with a pencil and paper or whatever they had available to them. They weren't actually drawing on the computer and taking pictures of these to build up a storyboard and do a voiceover to actually get a full animatronic at the end of the lesson. And so very sophisticated techniques in terms of what was actually being proposed compared to what you would normally see. And the interesting thing was to see that very young children, I mean the children that we had testing this out ranged from age 5 to some people who I wouldn't qualify as children actually, who were actually testing it themselves. But to see how people reacted to it and how much they understood and what they could actually do with this. When they provided their storyboard, the teachers, so this was generally Pat, if he had several volunteers helping her out to evaluate these, would send back a response, and the response itself was a video. So it was either a hooray, you did it right, congratulations, or a, you almost got it, you should retry and go over again. So this was an interesting type of method for providing feedback in terms of what was actually happening. This was entirely asynchronous basically the child would submit, we didn't know necessarily at what time they would be submitting, so one of the key issues with this was to go and make sure that we could deal with this asynchronicity and make sure that when a response came back, the child would be notified immediately that there was a response video coming back for them that would trigger some interesting things. Throughout the exercise, the child could navigate throughout to be able to see what they'd already submitted, what the responses were, but also see once any other student had actually finished their entire story. Because the goal of this was to get to a final story that you could share with others in the class. And the whole community who was working on this would actually get this. So it was pretty interesting to see how children could interact, be able to see what others had done, post comments, and do that sort of thing. So an interesting project. This is the basic summary of what we were actually looking at. So having known Pat for several years, when Pat described this and mentioned that she was having trouble finding developers to help her actually build it, said, given the immense amounts of free time I have when I'm not doing ACM or SIGGRAPH or my startup work, I could volunteer and I could go and do that. So basically volunteered to give her a hand in doing this. I've been working in 3D for a fairly long time, quite a lot of projects based on the interaction on the web. Felt pretty comfortable that I could probably do a lot of what she was asking for. We looked at this, and in terms of building out the 3D assets, we started using Ricardo's library, which was great. It was a lot of fun doing it. Actually worked like a charm, was doing exactly what we expected, tried a couple of things, and pushed the envelope to do even more than we originally planned as we discovered what we could do. We went back and forth with Pat in terms of let's test this, let's try that, let's see if we can make this sparkle, let's see what types of interactions we can provide. And started developing all of this. Pat was doing most of the assets herself in Maya and building out all of the actual geometry. Just a clear disclaimer, I'm a coder. You don't want to ask me to model anything if you want to look at it. So Pat did all of that, I did all the back-end coding for that. And the interaction was actually coming along really, really well until all of a sudden we ran into a problem. The one thing we had never thought to ask is what types of computers were actually in the classrooms. And it turned out that for a vast majority of the classrooms that we were working with, and even for the homeschool kids that we were working with, they were on iPads or iPods or iPhones, basically all on iOS. We had asked what browser they were using, and they had all answered Safari, forgetting to put in the mobile part. So all of a sudden, we were running around like chickens with our heads cut off, going, the sky is falling, it's the end of this. Basically, when this happened, of course, this was at the worst possible moment, because as we were looking at this, how do we go and save the project? This was less than 3 weeks from the project launch in terms of distributing it widely to the classes when we figured this out. So all of a sudden, we've got a whole series of assets that we can't use in the classrooms as we had expected. I tried to figure out, okay, how do we save this project and what can we do to be able to go and come up with a different solution that would actually let us go and help Pat get her, the data that she was looking to get, be able to keep as close to the original user experience that we had designed as possible. So try to stick to the storyboard as much as possible by having something that could actually work on an iOS device. Given the time frame, we're talking 2.5 weeks from delivery. We first looked to see, okay, do we feel confident that we can actually rewrite this directly as an iOS app? And I've done 2.5 weeks, given the fact that I'm not doing it full time, I wouldn't bet a whole heck of a lot of money to be able to do that, nor would I put her PhD on the line to be able to do that. So we came up with other solutions and started to look at this and say, okay, what do we have? Well, all the video assets were there, all the 3D assets were there. We had all of the content ready. It was all a question of how we would present it to users in Final Frame. So we did a first test where I tried rendering it as cube maps, and delivering it that way didn't quite work as well as we would have liked to because of the trade-offs between the size of the texture maps we needed for the cube map and the fidelity that we wanted to keep. We wanted to give some really interesting pictures that the children could play with, be able to give them a nice user experience, and still give them that sense of spatial location and see how you can actually do it. Now, one of the interesting things about how all of the geometry in our scene was actually set up is that we actually had 4 locales. So the actual geometry was set up in an arena where we had, in the 4 major quadrants, was where we would group the interaction pieces that we wanted to do, depending on what you wanted to do. So there's one group where you figure out how to use the software and what was expected of you. Basically think of it as your help area. There was one area where you could get lessons. So you could click on, well, there are eggs in here, to be able to get the lesson content and be able to see how that actually gets delivered and what you're expected to do. So basically that's where you get to find out what your next assignment is, plus get the feedback from the monsters to be able to figure out, oh, this is how this monster resolved it, this is how that monster resolved it, now I can figure out what I can do to be able to go and do my assignment. So I looked at that and said, okay, why don't we do something really simple? And it was basically said, okay, well, why don't we just render these in Maya, each of the quadrants, put ourselves at the center of the arena, and set them up as simple 2D image maps with all of the interaction zones set up as click areas, and do that, and give the sense of spatial location by putting it in a carousel, where as you go from one scene to the next, you are actually traversing the geometry in the order where it actually is. And we did some experiments with that, we got that up pretty quickly. And it actually worked much better than we anticipated. And we got pretty interesting to go and see how we actually got that. Now, one of the key things is all of the 3D interactions that we had previously were instrumented. We had everything ready to be able to collect all of the user's interactions so we could see, did they start by going to see a help video, or they attack the lessons without looking at the helps first. Anybody want to guess what we found for that specific question? Nobody went to the help. They all figured they knew it already, and that's their expectation when they get to AC. We were actually pretty surprised by that. And we found a very, very small number of students actually use the help. They just went straight to the interaction and clicked on everything until they figured it out. And it sounds pretty much like the way I use my software too, I think. I don't actually read what that is. So to give you an idea of what this actually looks like, here's the actual interaction. So basically what you're doing is using a slideshow carousel to be able to go through. You can look at a lesson, the lesson comes down, the video starts up. I don't think I'll bore you with this lesson itself, but give you an idea, you're actually playing this directly to get the instructions as to what it is you're expected to do. And you can go back, and then you can ask the monsters themselves, and they will show you how they resolve it. So basically, all these have animatronics behind them that the monsters have built in terms of giving each student an example that they can actually work from. So it's pretty interesting to see. The kids actually enjoy going to the monsters, going back and forth to see, okay, how do the monsters do this before figuring out what they would do. So there's some pretty interesting interactions with that. So just as we go through, you can actually see, so here, this is my account, and I only tried lesson 1. So here I can see what I submitted in terms of my lessons. I can click on it to see the video, get a sense of what actually came out. And then the final space, which is the space where you're actually going through, so this is the final quadrant where you can see who has finished a full story. And by default, you're seeing it in terms of the newest one, so there's always fresh content coming up. You can choose to go random or just see the stories that you've created. It's a very, very simple interaction model that we tried to go and do just to keep as close to the 3D as possible. Okay? So the interesting thing was to see, well, what did we learn from this? And it was, aside from a nightmare scenario when we were looking at the very tight deadlines to see how do we get around this, we decided to actually do a post-mortem on this and say, okay, the next time Pat is doing a PhD, we know what we'll do and figure out how we actually address this. So the key thing that we looked at was to realize that the core thing that we had overlooked was that none of the existing Web3D solutions work on every target machine. And we hadn't put a plan in for that to be able to have a backfill solution for target machines that weren't supported by it. And that was just poor planning. We knew about it. It got worse when we actually realized that we were in the worst possible case in that pretty much every single one of our users was using a machine that couldn't run WebGL. Or not without going mode anyway. So, if we look at what that means for WebGL currently, just looking at the current state, and hopefully this will change very, very quickly. But today, one of the major issues is the lack of consistent support on mobile. And we'll see as more and more vendors come on board and release into their production pipelines the actual working versions, this should go away. I mean, I'm crossing my fingers, can't wait to see an iOS version out there in production. The fact that it's available to developers leads me to believe that it's a question of time as to when it will be available, not a question of if, but we're not seeing it yet. The other outstanding one is, again, major lack is the lack of support on IE. And given the number of users that we see on IE, it's always a pain to have to go tell them, oh, switch browsers, go somewhere else, be able to do it. We'd love to see Microsoft come out in a not too distant release with a version that actually fully supports it. It would make our lives a heck of a lot easier. We wouldn't have to go and resort to backfill solutions to be able to go and provide the content across multiple browsers in a consistent way. And the key thing was to plan from the get-go to have graceful degradation. Is, okay, I may not be able to get the full 3D experience, but when I'm designing this, and again, this was my error when I started this out, was I figured, okay, I'll just assume that everybody's got it back and they're running Chrome, and we just won't worry about it. And then to find out very, very close to the deadline that, yeah, false assumption. So, things that we could have done a heck of a lot better in terms of what we actually planned for. Had this been planned from the get-go, I think we would have had a little bit less panic, and I think Pat would have had a much smoother ride of this in terms of how we actually got to her final PhD and see where we went. And then we started looking at it and saying, okay, well, how can we fake 3D? What is it when we're saying we're doing 3D interaction that the user actually cares about? And started thinking in terms of the projects that we both worked on to see how do you define an experience that users would qualify as 3D or 3D-like without necessitating the presence of WebGL. And again, the idea would be to assume that WebGL is present, but when it's not, gracefully degrade to an experience that was close enough to allow us to get away with it and give people the impression of doing things. So we started looking at other elements and saying, okay, well, how do we fake this? We basically came up with two others. So one is the one that I actually used for this project, which is, okay, use static image maps, carousels to suggest the placement of areas. And again, this would be like what you do when you're doing stuff with a version for browsers that can't do the full 3D. The idea would be to keep that full 3D interaction when you can, but when you can't, have something that suggests spatial placement of your scenes, puts them relative to each other in a way that corresponds to where they are naturally. If you were, say, in the center of the scene and looking around, if you're looking from left to right, make sure you keep that order so you can reinforce that sense of presence, that sense of spatial disposition. But the other thing is, well, there are things we can do with CSS3 that would work actually very nicely and that most people can't distinguish from real 3D. I'll tell you about some experiments that we've done with this in terms of various projects that we've done to actually look at this. So let's look there. First, what happens with static views and image maps? What do we do with this? Nice thing is it works in every browser. So this is the rock solid fallback that no matter what, I know I can deliver this, okay? Okay, not quite sure it doesn't work with links, but if you have a graphic enabled browser, you're not talking about text-based browsers. Anybody use links in this group? Oh no, I saw one here actually. Okay. Well, sorry, we won't be able to solve the problem here. Not with that browser. So there are certain browsers that you won't be able to go and work with. But the idea is, on pretty much any browser that you encounter, wherever you are, image maps is a safe solution, something that you can actually do. Bring it in with something like jQuery to be able to get a carousel-like effect, be able to do your animations so that you move smoothly from one to the other. Fairly straightforward and simple. The solutions are out there. There's a lot that you can choose from. You can pick what it is you want. The nice thing about this is you maintain the interactivity. So anything that's clickable in 3D, you can make clickable on your image map. So you're not losing a lot of the interactions if your interaction is click-based. If you're drag-based, you're screwed. So the idea is start thinking about your user interaction from the get-go and say, okay, if I need to go and gracefully degrade, look at everything as a click-based interface. Try and keep it that way so that if I can't use the full gamut of the tools that I would use in 3D, I still have fallback. I've got something where I can give people a degraded experience that resembles what we were doing. How many of you have seen the Wizard of Oz demo that's been done in terms of using, so WebGL in terms of what they've actually put out, a full 3D experience, sure. They've limited you in terms of where you can actually go along. You've got a hard-coded path. You can only walk along one path. You don't have full freedom to explore it. There, but it's actually a fairly compelling demo. How many people in the room have seen that? Okay, so a couple of you. The interesting thing is, have you ever tried it on iOS? Yes. Okay. Well, I'm not surprised. Okay. So if you look at what they've done with that, they've actually done pretty much what I'm describing here. They degrade to static image maps and a succession of them that you can actually move from one to the next to be able to go see your scene. So the points of interest are pre-rendered from the original 3D data, so you have no visual discontinuity between the full 3D experience and the degraded image map, which is the key thing, because if you've got 3D, well, I can render it out to a static image, and with a little bit of extra work, I can add on those image targets to be able to go and get an image map up, where anything that was clickable in my 3D is still clickable in the image map. Okay, and it's fairly straightforward. I'm not browser dependent on this one, it just works. One of the key issues you will have, though, and we found this out the hard way, was image maps are all in absolute pixels on the image, which is great when you've got a responsive design framework that you built this on, and that you're seeing is resizing. Your image map doesn't, or at least not straight out of the box. You're going to have to do some JavaScript magic in the background to make sure that everything resizes appropriately. If you're doing things like what you saw in ours, so if you saw the areas where I was showing the pictures of the videos that you had already done, or the pictures of everybody else's videos, that adapts to the screen size that you actually have. And there was a fair amount of JavaScript in the background to be able to go and make sure that everything resized with the image map. So those weren't click targets, those were actual separate videos that were hovering above the background image that we so some pretty interesting things that I hadn't expected, and was as we were testing, we realized, oh, the target has moved because the image map is in absolute pixels and the size of what I have is some fun things you find as you're actually doing it. But the key thing again is to remember that since you've got your 3D assets, if we're assuming what you started out with was a 3D scene where you have everything, it's pretty trivial to just render it out to a static image and be able to have everything you need. So another way to actually go and fool people, as I said earlier, was to use cube maps. So basically take a square picture on each of the principal axes in both directions and assemble them as a cube map. The nice thing is, fairly straightforward to be able to manipulate that in 3D with standard CSS. So using CSS3, what you've got is the full ability to be able to look around something that has been pre-rendered. And the cool thing is, if you're doing it that way, well, you can also use image maps there. We've also developed some interesting techniques that I'll go into in a couple of slides as to how you can extend that to a notion of a three-dimensional image map with divs that are placed in space at arbitrary orientations and placement. So you can actually extend this notion with some pretty interesting stuff. So rather than just talk about it, give you a demo, so show you one of these, and as this comes up, okay. So what we've got here, a nicely rendered image, and look through. This is a cube map. There's no 3D in there aside from these 6 faces of the cube that we used to render this. This was all rendered in metal images to be able to go and present. This is 4 separate clients that I'm working with. To be able to go and give them something that they can play on their iPhone if they want to. Okay? It's full CSS3. There's nothing else under the covers that's required. It just works. And it gives you an impression 3D. And you show this to anybody. And you ask them, is this 3D? And they answer yes. They think it is. Then you ask them, okay, well, can you move over to that door there? Can you walk there and get there? And then they realize there's no UI to do it. The reason there's no UI to do it is since this is a cube app, I can't. I've nailed your feet before. You can look around everywhere you want to and get that experience. And what we found in terms of experimenting with this, and the only reason I didn't do it for Pat's project was just the time required to do it and how much time I had available, given the fact that I do have a full-time job on the side that normally keeps me very busy. I wasn't sure that I could actually get the code necessary to get this up for her in time, so we went for a much simpler solution where I was sure to be able to deliver. But the key thing is with this type of interaction, you can make things clickable. You can actually go to them and use this notion, again, of image maps as a first base. And I'll show you some extensions to this on a project we did for a company called SceneCaster, where what we were doing is giving the user the ability to build a 3D scene that was decorated with their Facebook pictures. So I'll show you what that means. Okay? Let's get back from here. Go back up and go back to this one. Full screen mode. Okay. So that was the first sense. So it showed you what we could do. Wanted to show you that one because we actually focused on the rendering as the key aspect. Then I'll look at another element where we use cube maps, again, for the very simple reason that what we're doing, this is a project that I did in 2007. This was when Facebook had just opened up their API. And the contract that I had was to go and deliver a 3D environment to users who were not 3D savvy. So we're not talking about your die-hard Maya user who's very familiar with all the concepts, understands all this, and just feels comfortable in a 3D space. We were looking at your Joe Random Facebook user. So the expectation was they knew nothing about 3D transforms, had no background on this, but we wanted to give them an experience where they could actually interact and do things. And we started out with the first version where I wrote a custom plugin and required users to download a plugin to be able to do 3D. And in 2007, we didn't have very many choices. When Papervision was out there in terms of the Flash extension, the problem was the rendering capabilities of Papervision started falling apart and specifically would run into issues if your geometry was too complex. We gave users that ability, and what actually happened there was that we found that when you would follow how people were tracking through the application, you would get to the page that said, now download this plugin to be able to use this app. 95% of the folks who got to that page abandoned at that point. It was, again, something that we had expected. We didn't expect the numbers would be so large. Basically, what we were seeing was that people didn't trust us. And you see this company called SceneCaster, you never heard of them before in their lives. They're telling you that you want to install code on your computer and trust us immensely to do the right thing and not hack the passwords or anything else of the sort. It turns out that people didn't think we were trustworthy, and I understand. So we have to come up with another solution. So what we decided to do is to look at this and say, okay, well, could we come up with a different concept where what we'll do is we will build out the scenes, but we'll let you customize them with your pictures. So think of something where I built out a room like this room with frames on the walls that you can fill with your pictures. Okay? That was the concept of what we actually set up. And then what we wanted was that the full interactivity of this should be able to be done without any plugin. So a little caveat to that is the actual requirement was without any new plugin other than ones that you most probably had. So at the time, given this was 2007, and we didn't have very, very many choices available to us, we decided to build this in Flash. So this was a Flash application where we did all the 3D transforms of the cube. Used the exact same metaphor for the one that I just showed you earlier in terms of what we were doing to be able to allow clients to go and render with CSS3 by pre-rendering, putting it on the cube map, and look to see, look to see what we could do to offer them an interactive environment that they could control with their own elements and look at what it meant to have an extension of the notion of a 2D web page into what we call a 3D web space. And I'll show you an example of that, just to give you an idea of what I mean here. So let me show you this. So again, this is on my personal homepage. Realize that I still have this up like many years after having designed it. So let me just walk you around it. Again, no 3D involved here. This was all rendered, so pre-rendered, full global illumination with mental arrays. So trying to get the best quality out there in terms of what we actually have. And you see all these areas here. All these frames are things that you can fill with content. So here I've got one filled, that's me, just in case you didn't recognize it. And see, and that's actually taken from my Facebook page. So that's a picture that I've got up there. So we would tie this in, let you pick from your pictures, so only public pictures because of the rights management on Facebook, but everything else would allow you to do that. And then we looked and said, okay, well, what can I do with that? So started looking at some interesting things. So yeah, given the fact that when you've put images in a frame, you're not sure that you're going to be flush and looking at them. So we gave you the ability to go and get a separate view and the ability to go and click through to be able to see something else. So here, if you click through, you're actually taken to my Facebook page. Okay, you can get to see my brothers and sisters over here. Aren't you all over there? Okay, so to give you an idea of what we can actually do with that. So basically what we've done is we've put this whole element in there, and we've given you the ability now to link to other web pages. Again, nothing new under the sun. This is just a straightforward extension of what you do with links everywhere else. You click on it, you get taken to it. But then we started thinking, okay, well, what else can I do? So we looked at things where, okay, well, what can I do? I can go to another website. So this is another link to my Facebook page. Here on this window, I put a link to my Twitter page, and I won't bore you with that. We'll go through. But there's another interesting thing that we started playing with and discovered was, well, if I can link to other pages, couldn't we use a means to tell the system that what we're actually linking to is another 3D scene? So we actually allow you to go directly to another scene. So basically what I've just done is teleported. Okay? So here, if you think, what we've done is we've put in this notion of I can either link the way I normally do to any web page with everything that's out there, or I can extend that notion to the fact that I'm in a 3D context and I can put teleport links. What does the teleport link take? It takes basically an identifier of the scene that you're going to, and then that scene gets loaded and starts displaying. So you can actually go through and see, all the fun we have at SIGGRAPH and see what you can actually do there. So all sorts of interesting things that you can do with these concepts. And again, you can mouse over to go and see what's clickable and what's out there. There are a series of things that we can do and see, okay, here I've linked to another scene. So now we've gone to this pool scene. So by doing all this, we've taken this notion of links on the existing web, which are essentially, think of them as links to a context that is by default a 2D context, and extended that to be able to know that, well, if my target is another 3D scene, I don't need to go and reload the whole page. I just reload the context that I'm in, and by default, unless you specify a different target, it plays in the same area you're at. And the reason to do that is to give you this sense of teleportation. And it's like, okay, I've gone from one scene to the next. Okay? So some pretty interesting concepts that we've been playing with. And then, given the issues that we had with Pat, I started thinking about what are the real problems that we see by using 3D on the web today, and could we take all these solutions and see what we can do with them? So let's look in terms of, first of all, what are the constraints that we have with cube maps? First one is, what I've done is effectively nailed your feet to the floor, okay? You can look around anywhere you want, but you can't move. Okay, that's basically what it comes down to. You can do most of the interactions that you could do in a scene, aside from changing the geometry and moving things around and changing the colors. They'll stay pretty much the same. And anything that's click-based, that's select-based, those elements you can keep. And if you keep that in mind when you're designing the 3D interaction, basically you can come up with an interaction where, in the case where you're capable of doing it, you can walk around, but on an iOS device or in IE, for instance, you can still look around, you just can't walk. Okay? And the key thing is, by doing that, you can also extend the notion of image maps. And this is what I was talking about earlier. You notice the frames that I showed you in the last demo there, where what we did is I had these yellow gradients in there to indicate where you could place an object. So when you're in edit mode, that comes up, brings up a select tool to let you go and say what images can I put in there, or what videos, and we support YouTube videos in that as well. And we extended that to this notion of rectangular regions in space. Again, if you think of this as being, again, it's a cube map, so think of it as a unit cube, and basically all you have to do is scale the rectangle in 3 space to bring it within that cube, and all of a sudden, all you have to do is do a painter's algorithm to be able to render first the cube, and then the content that's inside the cube, to be able to go and place it accurately where it was. So when you saw that picture of me, that's actually a rectangle hanging in space halfway between the cube edge and my virtual camera. That is actually a full div placed directly to be able to go and do that. So you have access to all of the tools that you would normally have in HTML to be able to go and do that. And again, nothing spectacular in this one. This is actually pretty straightforward. If you understand the math to be able to do all the matrix, transformations, pretty easy to do. Okay? And the key element that we got excited about was this whole notion of extending the 3D web page metaphor to 3D web spaces. And I think there's a lot that we can do that. I'm thinking of, the 3D solutions on the web as a way of implementing that. Thinking, what does it mean to teleport? What does it mean to change space? Where what I'm doing is I've got elements that I can click on, and these clicks can either activate local elements or be able to go and take me to another web page or to another web space. Okay? And the key thing is that any object can carry a link. By doing that, you can actually translate that into whatever you need to do for your image maps. Just to give you an idea, for the scene that I showed you earlier where you could click on objects that could carry links, the way we actually did that is we have a hidden buffer in the back that we actually call an ID buffer. So that buffer actually contains the ID of the closest object to the camera. So it's just rendered with a very simple shape that gives you the actual identifier. So in our case, it's actually a number under the covers. In the actual list of objects that are present in the scene to let me know what I've got under each picture, which means it's a trivial transformation to be able to take where did I click and find out what's that object, and then see was there a link attached to it, and do I do any special treatment to it. Okay? So pretty straightforward. And, okay, basically saying stuff that I already said earlier, so yeah, so where you have links, you can also do any sort of JavaScript callback to do what you want. So now let's look at full 3D, and here I took one of the Vue.js examples of the card demo, which I'm sure you've all seen, just to give you an idea of what's actually happening. Now, the interesting thing here is that this is actually pretty much all cast. Let me try this out. And when you get through it, what do we see here? So, remember that I had already loaded this one because, of course, I was reversing earlier today. And what you saw was the time it took to load this, despite the fact that everything is pretty much cached. We saw there about 5 seconds worth of load time. If it's not cached, you're talking about 30 seconds or higher. Okay, so user experience is pretty great. And we like to be able to go and address that. So one of the key things that I've been looking at is, well, couldn't we combine the elements that we've been looking at before to be able to get a progressive loading environment that would let us go and address the latency by giving you successive representations of the same scene. And if you're using the same renderer to do this, so say, let's take WebGL as a renderer to be able to generate my cube maps and my image maps, so I have no disparity between how it looks depending on which one I'm using. I can then progressively load each one and get an experience that makes the whole thing seem to go faster despite the fact that it's not. On top of that, I get the ability to be able to go and start interacting very, very quickly. Pretty much as soon as key assets start loading, I can start to interact. So let's go look and see what that actually means. And we'll talk about that. Okay. So, what are the pros? I can now walk around. I can go anywhere I want to, though in that last demo, your feet are actually, well, it's not so much your feet are nailed to the ground, as you don't have any choice. You're being walked around the object that you're looking at, but the idea is potentially the interface gives us the freedom to go anywhere we want. We could. Okay? I have the key element that will differentiate from all the other modes is that I don't have to worry about a static render. I can change the rendering parameters, even the geometry, swap geometry in and out, make animations, do all that on the fly. I won't be able to do that in any of the degraded modes. I have full interactivity. I now can do drags, move things around, which I couldn't do in any of the static modes. Okay? And again, full animation capabilities. What are the cons? As I mentioned earlier, the problem with this full 3D solution is that I'm not guaranteed to be able to run it on every device that I encounter. And I'm not even talking about links. We can go there. Load times are a pain. And again, the latency is the killer in every 3D app that I've seen today. Okay? Basically, we're dependent on the size of the pipe you have to be able to get your assets. There's not much we can do about that. Now, there's some great things we can do with compression to make the latency less objectionable. But there's still lots more that we can do. And where if we can do a progressive load and we can cheat a bit, my sense is we can make the user experience so much better by giving people something that they can interact with immediately, or immediately in terms of what you're used to seeing on the web, and start doing that. So what would that mean? So it's basically taking the three approaches that we've looked at. So basically static image map, cube map, and full 3D. Start with that. So what do you start off with? Well, the easiest one to deliver, that's a static image map. It costs you one image. Okay, and if you look at what it takes on any web page, that's generally delivered fast enough to be considered pretty much immediate. Okay? The advantage is you have the ability now to start interacting as soon as that's loaded. You can provide a fair amount of user feedback, give them the ability to start doing things, and move on. The next step, while you're actually doing that, the user is interacting. So right now, as soon as I've downloaded the first image, I can start the interaction. In the background, what I'm doing is loading the 6 faces of the cube. Why am I doing that separately? It's because it's 6 times longer. Okay? Simple math in terms of the amount of data to bring down. In terms of the objects, yeah, there's a little bit more objects, given the fact that you have a wider field of view, since you can see all around, up and down, and have a lot more potential objects to click on. But you're still talking about the same order of magnitude. Once you've got that, then shift into cube map mode. Now the key thing is, we know where you're looking, or where you were looking, in terms of that first image, because that's the initial camera position, is how you actually delivered it. So just align the cube map for that, start it in, and fade it in and fade out the old one you can't see anything change. It's visually imperceptible, which is actually pretty cool because you don't see that it's actually doing things, except that now you can start looking around. So in terms of how you provide the user feedback, see that all the widgets you had, all the buttons that you had that would let you look around, have them grayed out at first, and now activate them to show the user, give them visual feedback, okay, you can start looking. But while you're doing that, you can be loading all of your 3D assets. And remember that what we've done is we've actually rendered these using the same renderer that we use to be able to go and render the interactive, which means that by the time they've actually fully loaded and I have everything I need to be able to do the full 3D, I can simply fade out my cube map, make it go away, and what you see is a 3D renderer that's in a layer behind it that appears, and again, you have the same camera controls, you have the same areas that you're looking at, you know what your field of view is, where you were looking, so they align, and there is no visual artifact in terms of what is actually changing. So what you've done is you've gone progressively from loading an initial image that gives you first limited feedback through to cube maps, through to a final full load of the elements to be able to go and progressively give more and more interaction capabilities while keeping a consistent view. Okay? So, the cool thing is, I can do that today. Just a bit of JavaScript. Okay? So a little care and feeding, planning in terms of how you actually design your assets and what you're actually doing, and saying, okay, how do I actually build that up? But for me, that's not enough because I don't believe that there are enough people who are willing to put in the sweat to be able to go and do this. I would love to see what we could do. And remember that this actually serves two purposes, because now I've got full browser detection, I can tell whether WebGL is available. So I could do something where after my first two passes are loaded, if WebGL isn't enabled, I just stay with QMAP. And we limit it at that level of interactivity. And I still maintain one scene description. It's one common description of what my scene does and what the interaction is to be able to go and do it. And what I'd like to see is, what if we designed it so that this whole process was automated, because there's nothing that requires a human involved in this. It's all entirely automatable from the actual scene description itself. We could actually extend this directly, put the scene description up, and then run through to be able to go, pre-render, have everything ready, save it aside, and be able to serve that up. Okay? And one other thing that I would look at is to say, okay, make it simple. Why don't we have something like a scene server that understands what I need to deliver to my client to be able to go and do this progressive rendering? Not put the onus on the developer, because we'd all be writing the exact same code with minor modifications, and there's no point. This is something that seems ideal for a service and a library to be able to go manage it. Give yourself something that gives you a JavaScript call, would be a 3D scene load, whatever we decide to call it, that takes the scene ID and the target div ID and does all these manipulations within the target to be able to go and bring you this progressive rendering. And one thing that I would look at, and again, I don't know that actually defining a new link type is the right way. We might be able to pull it off with bind types just by looking at the type value to be able to see what behavior to have. It's just that if we introduce the scene types, and the reason I went for this one is because that's what we actually did in the implementation that I showed you. We actually identify it as a 3D scene by giving it 3D scene cone rather than HTTP cone as the specifier for the protocol to come through. And that's just a hint to be able to tell us that what we need to do with that when we're in the context of a 3D scene is to teleport rather than go and replace my current web page with what I would have. Okay? So that's the way I've been thinking about this and looking at this as a result of the problems that we ran into with PAX thesis. And that was the sense of my talk. Oh, yeah, one thing. Okay, the teleports are moving together. And as we look at that and see what we can do, what are the advantages we get from this? So you look at this and say, okay, well, 3D scenes now become first-class citizens on the web. And again, what I very, very much like with Ricardo's approach is that it made the loading of 3D data brain dead simple. And just to give you an idea, I give talks in the high schools in Toronto where I use 3.js to help kids over a 2-hour session come out at the end of the session with a 3D scene that they have built themselves and coded in JavaScript. The kids are ecstatic about it because what they've done is they've learned a little bit of coding. They didn't learn very much. We're basically deriving from existing scenes and putting in the assets that they would choose to put in, learning some simple manipulations as to how to do translations and how to do elements like that. But what they come out with is their own website that I host actually on my website for them, but then they can show their friends. And anything we can do to make it simple, to create a 3D scene from existing assets, so things from the Google 3D warehouse, from libraries of objects that you can assemble and put into something that you would use, is something that will help go and spread the, well, hopefully the enthusiasm for what we've got there. Okay. The idea is, keeping the whole HTTP semantics in this by introducing a 3D web with this notion of teleport capabilities. It's straightforward. It's basically thinking of your 3D spaces as web spaces that carry weights, and the whole notion is the same. Keep it the same as what we're used to. The model works. People get it. There's been, since what, 96 now, is it? Since we had the first publicly available browsers really out there. Yeah, okay. We've had a fair amount of experience and it's successful. People understand how to click on things. There is still the notion of, how do I translate this whole notion of the blue underscore in 3D? It's, what do we do to show people that things are clickable? And it's still some work to be done there to be able to get some common metaphors and common language, to be able to spread that out so people can understand where can I click without hovering over everything to see if it lights up or pixie dust comes out of it. It's, there are things that we haven't quite solved yet that we need to go and look at. But we're almost there. There's some really, really simple things. And what I like about this is that it offers itself up to a notion of a streaming protocol where basically what you do is you have a scene ID. Since you're getting in your HTTP request, full description of the browser if you haven't overwritten your user agent string, we already know on the server side how far we need to go in terms of what we need to deliver, and we can deliver all the assets through the streaming protocol that could help you actually progressively load and do this in a single call. Okay? This is the sort of thing where by having these collections of 3D scenes out there that you can call through a simple metaphor, what we then have is the ability to go and have many people use it to start building their own. Would we need to create the authoring tools? Yeah, definitely. There's a fair amount of work that we need to go into that. But the amount of work that's involved compared to what's already there in terms of 3D authoring tools isn't all that big. It's not that different. So I feel that sort of approach is something that would let us actually go and do this and give you the ability to work around the existence of browsers that don't support HTML. Because now what we've done is we've built into the streaming protocol and say, okay, stream as much as makes sense for the browser that I'm currently in. If I understand WebGL, continue streaming until I have all my 3D assets and let people work through it. If I don't, stop at feedback. And you already have a graceful degradation in terms of what you're actually sort of doing. So, model that I'm proposing in terms of concrete problems that I've encountered, and just something I want to go and share with you. Yeah.